All right, let's talk about something that's absolutely critical for anyone building on AWS: how to properly secure your Amazon DynamoDB databases. We're going to peel back the curtain layer by layer and make this whole thing super clear and, more importantly, actionable for you.
So picture this. Your application is live, people are using it, everything's running smoothly. But there's that nagging question in the back of your mind, right? Is the data that's piling up in my DynamoDB tables actually safe? It's a question that can definitely keep you up at night, and today we're going to tackle it head on.
So where do we even begin? Well, before we can talk about any specific feature or policy, we have to get on the same page about the most foundational concept in all of cloud security, and that is the AWS shared responsibility model. Honestly, once you get this, everything else just clicks into place.
Think of cloud security like a partnership. AWS handles what they call security of the cloud. That's all the stuff you don't see: the physical buildings, the servers, the network cables, the actual infrastructure that powers DynamoDB. They've got that covered. Your job is security in the cloud. That means you are in the driver's seat when it comes to your data. You decide who gets access, how it's classified, and how you set up all the security tools AWS gives you. At the end of the day, it's your data, so you get to control the locks.
Okay, so let's start at the front door. This is our first and broadest line of defense, the main entrance to our entire DynamoDB setup. And the ones checking IDs at the door are our gatekeepers, AWS Identity and Access Management, better known as IAM.
IAM policies are your big, high-level rules. You can think of them like the main security desk in a giant office building. Their job isn't to worry about which specific office you're going to. Their first job is to figure out, are you even allowed in this building at all? In our case, the building is the DynamoDB service. This is your first and arguably most important layer of control.
And check out the scope here on these AWS managed policies. The full access v2 policy doesn't just give you access to DynamoDB. It's smart enough to know you'll probably need DAX for caching or KMS for encryption, so it includes permissions for those too. Same with read-only access. It lets you see into those related services, which is crucial for things like monitoring. Choosing the right one is your first big step in applying what we call the principle of least privilege. Only give the permissions that are absolutely necessary.
And hey, here's a really important heads up. The original full access policy, the one without the _v2, is on its way out. If you're still using it, you've got to start planning a migration to the _v2 version, because come April 2025, it gets officially deprecated. After that date, you won't be able to attach that old policy to any new users or roles. So yeah, this is a change you'll definitely need to make.
All right, so our user got past the main gatekeepers. They're inside the building. But that doesn't mean they can just wander anywhere they want. Now we need to get more granular. This next layer is like handing out specific keys for individual rooms, or in our world, individual DynamoDB tables. This is where resource-based policies come in.
Now this is a total mind shift from IAM policies. Instead of attaching a policy to a user saying, hey, you can go access these tables, you flip it around. You attach the policy directly to the table. And it says, hey, only these specific users can access me. This is awesome because it puts the permissions right on the resource itself. It makes it so much easier to look at a sensitive table and know with certainty exactly who can touch it.
Looking at a policy document can be a little intimidating at first, but it's actually super simple. It's really just answering 4 basic questions. Who is this rule for? That's your principal. What are they allowed to do? That's the action. What specific thing can they do it to? That's the resource. And finally, the big one. Are we letting them do it or not? That's the effect. Allow or deny. That's it.
And when you put it all together, all that JSON code boils down to a simple sentence you can actually understand. This policy gives John the room key for the music collection table. And that key is very specific. It only works to get items and put items. He can't use it to delete the table. He can't use it to get into any other tables. Now that is granular control. Okay, but what happens when you're growing fast? You've got tons of developers, you've got dev environments, staging, production. Trying to manage individual room keys for every single person and every single table, it just becomes a total nightmare. It doesn't scale. You need a better system, something more like a special security clearance, and that's exactly what Attribute-Based Access Control, or ABAC, is.
ABAC is an absolute game changer for managing permissions when things get complex. The whole idea is that instead of writing policies that call out specific tables or users by name, you write policies that refer to tags. The rule is simple.
If the tag on the user matches the tag on the resource they're trying to access, access is granted. It's dynamic, it's scalable, and it is seriously powerful.
Let's walk through a quick example. Imagine you have a policy that says you can only mess with tables that have the tag environment production if you, the user, also have that same tag. Simple enough, right? So a developer who only has a dev tag tries to update a production table. What happens?
Nope, access denied. Just like that. The system looks at the user's tags, sees dev, looks at the table's tags, sees production, they don't match, and boom, the door is shut. The policy did its job perfectly, and our production data is safe.
But now, watch this. This is the magic. Let's say that developer gets promoted. We go in and just add the environment production tag to their user profile. They try the exact same action again on the exact same table, and this time, it's allowed. We didn't touch the policy, we didn't change a single line of code, we just changed an attribute on the user. Now imagine doing that across your entire organization. That's the power and scalability of ABAC.
So we've controlled who can get in the main door, and we've controlled which rooms they can enter. But what about the actual stuff inside those rooms? What about the data itself? Well, for our final layer of defense, we need the digital equivalent of a high-security safe, encryption at rest.
And here's some really, really good news. This is one of those things you don't even have to think about turning on. DynamoDB encrypts 100% of your data by default, using the super strong AES 256 standard. This protects your data if someone were to somehow get unauthorized access to the underlying physical storage. So the choice you have to make isn't if you should encrypt, but how you want to manage the encryption keys.
And you've basically got 3 flavors to choose from. The AWS-owned key is the default. It's free, it's zero config, it just works. Then you have the AWS managed key. This one costs a little bit, but it gives you the ability to actually see and audit how the key is being used right in your own account, which is a huge plus for compliance. And finally, for maximum control, you have the customer managed key. You create it, you own it, you manage its policies, you can rotate it whenever you want. This is the one you choose when you have super strict security or compliance rules to follow.
So let's just do a quick recap of our security journey here. It's all about layers. Layer 1, start broad with IAM policies, your main gatekeepers. Layer 2, get specific with resource-based policies, your individual room keys. Layer 3, make it scale with ABAC and tags, your special clearance. And finally, Layer 4, protect the data itself by choosing the right KMS key for your digital safe.
You know, security is never really a one-and-done kind of thing. It's a continuous process. So as you look at these layers, from the big picture access control all the way down to the nitty-gritty of encryption, I want you to think about your own applications. Which one of these layers is the biggest opportunity for you to level up your security game right now? Thanks for joining me.